Problem Introduction. Hey everyone, and welcome back to the channel. Today we're tackling LeetCode problem number 48, Rotate Image. This is a medium difficulty problem that often shows up in coding interviews, so mastering it is a great boost to your skills. The problem statement is straightforward. You're given a square matrix, represented as a list of lists in Python, and your task is to rotate the image by 90 degrees clockwise. Think of it like taking a picture on your phone and rotating it to the right. We're not allowed to create a new matrix. We have to modify the existing one in place. This in-place modification constraint adds a layer of complexity. So we'll dive into various approaches to tackle this challenge efficiently and effectively. Let's get started. Understanding with examples. Let's understand this with a simple example. Imagine a 3x3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. After a 90-degree clockwise rotation, what do we expect? The first row, 1, 2, 3, becomes the first column in the rotated matrix, but in reverse order. So it becomes 7, 4, 1. Similarly, 4, 5, 6 rotates to 8, 5, 2, and 7, 8, 9 rotates to 9, 6, 3. See how each element moves? The element at nums at position ij moves to j n-1i, where n is the size of the matrix. That pattern's key to solving this problem. Let's consider another example, a 2x2 matrix. This will help solidify our understanding before we move to the algorithmic solutions. Working through these examples allows us to visualize the rotation and understand the underlying pattern crucial for efficient code design. Brute force approach. One naive approach, a brute force method, would involve creating a new matrix, iterating through the original matrix, and populating the new one with the rotated values. This is simple to understand but computationally expensive. We'd end up with a time complexity of O of n squared because we're iterating through all elements twice. The space complexity would also be O of n squared because we're creating a whole new matrix of the same size. While straightforward, this approach isn't optimal, particularly for large matrices. For this kind of problem, in-place modification is generally more efficient. That's why we'll focus on a superior solution in the next step, optimal solution. The optimal approach involves rotating the matrix in 4 steps using in-place operations. First, we transpose the matrix, swapping each element, ij, with ji. Then we reverse each row. This method cleverly uses the matrix's structure to achieve the rotation without using extra space. Transposing changes the orientation, and reversing each row completes the 90-degree clockwise turn. This elegant solution significantly improves performance compared to the brute force method. Because we're manipulating the existing matrix directly, the space complexity is O of 1, meaning it's constant regardless of the input size. The time complexity, like the brute force method, remains O of n squared because of the iterations needed for transposing and reversing. However, due to its in-place nature and computational efficiency, this optimal solution is the preferred method for this problem. Code implementation. Let's see the code in Python. We'll implement the optimal solution we just discussed. First, we'll transpose the matrix. Then we'll reverse each row. This will result in a 90-degree clockwise rotation. I'll break it down step by step so you can follow along easily. We'll first iterate to transpose the matrix, then iterate again to reverse each row. We use built-in Python list methods to make the code more readable. This is the preferred coding style which avoids unnecessary looping. Remember, readability and efficiency go hand in hand in coding. I added comments to the code so you can always review. This should leave you well equipped to solve the problem in future interviews. Time and space complexity. Now let's analyze the time and space complexity of our optimal solution. The time complexity is O of n squared because we're iterating through the matrix twice, once for transposing and once for reversing rows. This is the same as the brute force approach, but we improved the space complexity. Since we're modifying the original matrix directly, we don't use extra space that scales with the input size. Therefore, the space complexity is O of 1, constant space. This makes our solution much more efficient, especially when dealing with large matrices. By avoiding extra space usage, we've significantly improved the overall efficiency of our algorithm. Engagement break. So, there you have it. We've successfully tackled the rotate image problem. Before we wrap up, I'd love to hear your thoughts. Did you find this explanation helpful? What other LeetCode problems would you like me to cover? Let me know in the comments below. And don't forget to like this video and subscribe to the channel for more coding tutorials and problem-solving sessions. Hit that notification bell so you don't miss out on future uploads. Your support means the world to me. Conclusion. In this video, we explored the LeetCode rotate image problem, understanding its intricacies, and implementing an efficient solution. We began with a brute force approach, highlighting its limitations, and then moved on to an optimized in-place approach using transposing and row reversal. We analyzed both the time and space complexities, demonstrating the significant improvement achieved through our refined solution. Remember, understanding different approaches and choosing the most appropriate one is key to effective